Hello, this is Nolan Hartwick. This is the January 22nd review session for the UCSD Data Science Visualization course. And tonight I plan to be covering some fundamental, I already forgot the words. Variable keywords related to variables, as well as JavaScript functional programming, as well as how the many ways to define a function in JavaScript. Mm-hmm. Does anyone have any questions before we begin? Okay then, I'm just gonna go ahead and dive right in. You should see my screen, and on my screen we have this file called review.js. This file is linked inside of index.html. As a result, we can simply open this HTML file in the browser, and that will take us to our page. And opening that page will run our JavaScript. So go ahead and refresh that. And where did it go? Here. Okay. So the first thing that I wanted to demonstrate is exactly what the var keyword does. When we were talking about it in class, we kind of presented the var keyword as something that you use to declare a variable, and that's not exactly true. What var actually does is let you declare a local variable. It's a variable that can only be accessed by other items in the same scope. So in this case, because I'm declaring it inside of a function, only y can only be accessed from inside that function declaration. If you don't use var, then you're going to get a global variable, which can be accessed from anywhere. So down here, I go ahead and call this function really quick, which is going to just define x as a global variable and define y as a local variable. As a result, when we attempt to print x, it's going to work. And if you go to console, you can see that when we try to print x, we get the value 5. It works just fine because x is a global variable. We did not use the var keyword, so it's accessible from anywhere. Whereas when we try to access y, JavaScript complains that y is not defined, because y, as far as the JavaScript interpreter is concerned, only exists inside this function. So why would we want this behavior, right? It seems like you're just limiting yourself by making variables not be accessible. The answer is that often you don't want your variables to interfere with things that are happening outside of your function. So for example, if I define y out here as y equals 5, by saying var y equals 7, it creates a new local variable inside this scope, and this value of y will not be changed. And if so that's why you would want to use the var keyword. Any questions on what the var keyword does, or local versus global variables? Okay.
Hi, Nolan.
Yeah.
Yeah, sorry, I came late. But why bother using var then? Why not just use global?
Well, like, imagine that I have a variable out here. Imagine I have y defined out here, right? I don't want calling this function to change the value of y. I want y. Y is just something that I'm using in this function. It has nothing to do with the things outside of it.
Okay.
And by declaring var y, it creates a new local variable y that you can use without influencing the things outside of your code, without influencing things outside your function.
Okay.
Does that make sense?
Yeah.
Cool.
Nolan, if I had a function inside of demonstrate var, and
Yes.
would that function be able to access y?
If you define a function here, like this is what you're talking about, right? Function, some func, you would be able to access y.
Okay, so anything like above it, sort of like outside of
below the like anytime you declare a function, it inherits access to variables above it.
Oh, above, yeah.
So this y is at the same level as the function, so the function will have access to it. If I continue doing this,
it will still have access, right?
It will still have access to it.
Okay, but not the other way around, because if you declare something inside some other function, then the function.
Yeah, if I say var g equals 2, then I would not be able to access g out here. It just wouldn't work. I would get the same error I was getting before. Any other questions? Okay, then let's just go ahead and edit my source code real quick so that we can keep running this. Now, this next portion of the code is about demonstrating the const keyword. When you declare a variable using the const keyword, what that does is make it so that the variable cannot be updated. You can read from the variable, you can use it as part of function calls and stuff, but if you try to overwrite it, JavaScript will say, no, you're not allowed to do that. So for example, here I declare a constant z to be equal to 6. I'm perfectly allowed to use z. I can write it to console. But the second I try to update it, the second I try to assign a new value to z, because it's a constant, it will throw an error. It will complain that I'm trying to do something I shouldn't be allowed to do. So let me just quickly refresh this. Should have refreshed. Go to console, uncaught type error, assignment to constant variable at line 35. So once again, we assigned z to be equal to 6. We were able to read from it without any issue. But because it's a constant, we cannot write to it. And attempting to do so will result in an error. Why would we want this? The answer is a little bit less clear than before, where in general, you want to use the const keyword when you know that a value should never change. And what it's going to do is protect you from a variety of programming errors that you could make. Like, for example, let's say you define the URL of a website as a const. You know that that URL should never change. It should be that value that you define it to be, and any attempt to change it in your code is an error. Then you could define it as a const and make it true that in your code, it will never be updated. Does that kind of make sense?
Yeah.
Any questions related to the const keyword?
No.
You can, of course, use both the const and var keyword if you want to. You can say const var, or var const, I think. Something like that. I've never really had the need, but in principle, you can do it. All right, moving on. So those are the two biggest keywords related to variable declaration that I wanted you guys to know. The next thing that I wanted to talk about is, let's actually ignore this. Let me just quickly, let's skip this and go down to somewhere else. All right. There we go. All right, I've just commented out a big block of code because I wanted to talk about how we can define functions in JavaScript. We actually have like 3.5 ways to define a function in JavaScript. There's the standard named function, in which you simply use the function keyword, give the function some name. You have your arguments, and then you have some function body inside of brackets. This is the standard way to define a function. You're going to see it all over the place, but it's not the only way. We can also define functions as anonymous functions, where we don't give them a name. So in this case, we use the function keyword, and then we just immediately have the parentheses, and we can define however many arguments we want, and then we have the function body just like before. This can be
Why do we do that?
I'm sorry?
Why do we do that?
We generally do this when we want to use the functional programming interface. So you remember when we were using for each?
Yeah, but isn't it the same?
It's mostly the same. This is a little bit cleaner some of the time.
Okay.
But yes, you can do it however you want.
Okay.
If you want to always use named functions, you are free to do that.
Isn't it kind of like Lambda in Python?
It's exactly like Lambda in Python. Okay. Like in truth, the arrow function syntax is more like a Lambda in Python, but it's the same idea. There are multiple ways to define a function, and which way you choose to use is kind of just dependent on what makes your code more readable. And that's a personal decision that you're going to have to figure out. I can give you guidelines if you want, but for the most part, it's about what you're comfortable with.
Wouldn't it be mostly like when you want to call it over and over and over again, so you don't have to just keep writing it? Isn't that the main purpose, or am I missing something?
It's
with the anonymous functions, like Lambda and the arrow, or.
Well, it's really just the only time you should use anonymous functions is when you're passing that function to a for each or a map or a filter.
Okay.
That's pretty much it. Unless you're using for each, map, filter, or reduce, or some other higher order function, then you should just be using named functions.
Okay.
So the final way to declare a function in JavaScript is to use the arrow syntax. And when you use the arrow, what you're doing is stating that I have some number of inputs. And if you have multiple, you would put them inside of parentheses. So you could have my func equals input 1, comma, input 2 goes to 0. That's acceptable. And then you just have a single statement, which would be returned. So if I ever call my func, so this will always return 0. And I can quickly verify that if you want me to. But this is once again just another way to define a function. And you can use it if you want, you do not have to. The final way to define a function is just more of a note about the arrow functions. If you have a single statement to the right of the arrow function, the value of that statement will be returned by the function implicitly. Because there's nothing over here, basically, it's just a single statement. In this case, it's even simpler. It's just a single value. Anytime you call the function, it will return the value that the statement emits, that this statement is equal to. If you use brackets, then you have to use the keyword return. If you want your function to return something, use brackets, you have to explicitly state what you're returning. So yeah.
Huh.
These 4 examples are basically the 4 ways to define a function in JavaScript. Now, we can use whichever method we want when we're using the functional programming tools, but this right here with the arrow function is a lot cleaner than this once you're used to it. Like, it's not just because there's 1, it's 3 fewer lines of code. 2, you don't have this variable named sum that you're never going to use. Here, we just define the function really quick and we're done. But does anyone have any questions about the 4 ways to define a function? Please don't ask questions about the functional programming interface. I'm going to go over that next. Anything?
No.
Okay, then. Perfect.
What is that 0 for at the bottom?
Here,
Yeah.
I will be discussing that when I cover the reduce function.
Okay.
All right, so we're done with that, which means now we can go ahead and comment all that out because I don't need it. And go back up here, and we can start discussing functional programming in JavaScript. Now, in order to do this, it helps to have some type of example data to play with. In this case, I just created a list real quick of mostly random values. One of the key things to understand about the functional programming interface in JavaScript is that you never have to use it. Anything you do with filter, map, reduce, or for each can be done with a traditional for loop or while loop. It all comes down to what you're comfortable working with. So, for example, if we wanted to sum the values in this list, we could just use a traditional for loop. It's very straightforward. I'm pretty sure you all could read this and write this if you wanted to. Any questions on this simple use of the for loop? Okay. Now we get into the fun stuff. Just because you can use the for loop doesn't mean you have to. In fact, in a lot of cases, it's a lot easier to just use one of the functional programming tools that are for each, map, filter, and reduce. So here, I've decided that I want to use the for each method to sum the numbers. And to do that, you would just create, it's a lot like before. You define your value that you're going to be increasing, and then you pass for each a function that will add the value of x to some val. And what this will do is, for each value in my list, add that value to my sum val. And then we're going to write the sum value. So we can go ahead and see that in action if I save and reload. So here we are. We're going to use the for each method, and we're going to just quickly log the result. When we were using normal iteration, we got a result of 561. When we were using for each, we got 561. Great. They agree with each other. Like I said before, you can do it either way you want. It's up to you. At this stage, you may be wondering exactly what for each does. And in my experience, the easiest way to understand it is to just see an implementation of it. So for each is a library method of list objects that expects you to pass it a function and that function will be called on every item in the list. So what I've done here is basically define a version of for each. It accepts some list as an argument. It accepts some function that we're going to call on each item. And then we simply loop through the list and call our function on each item in the list. That's all for each does. It's that simple. It's 4 lines of code, and you have implemented it. Just to quickly verify that this is correct, I went ahead and used my version of for each to sum the numbers. We pass it in the list, we pass it in the same function we were using before, and we log the result. And here we are in the console, and we get the same result. Any questions on for each?
No.
All right. Once again, I just want to stress that you can code however you want. If you want to use normal for loops and while loops, more power to you. If you want to use for each, map, reduce, filter, go for that too. It's up to you. So that's for each. Now we can try doing it with the map function. And the map function is a little bit different because instead of just calling your function on each item in the list, it's going to call your function on each item in the list and store the value returned by your function. So in this case, I'm able to keep a running sum of the numbers as I'm moving through the list by simply updating my sum value and returning the current sum value. As a result, the return statement, the value returned by this function call, by this map call, is going to be a list the same size as my original list of numbers. And it will basically be a running sum of the numbers as we move through them. We also have sumval that we can print. So let's go ahead and run this. And once again, when we use map, we get the same result, 561, but we also get this running sum. 10 values, 75 plus 57 plus 29 plus 83, so on and so forth. In general, you want to use map when you're trying to convert the values in a list to some other values in an equally sized list. It's a lot like list comprehension in Python. As before, you may be wondering what map does. And for your convenience, I went ahead and defined a version of map, which makes it explicit what it does. It's very straightforward. We define a list that we're going to collect values in, and then we iterate through our list of values. We call our function on each item, and we add the result to our return list. We then return the return list, and that's all map does. 5 lines of code. It's pretty simple. It's very much like for each. The only difference is that we are storing the results of each function call. And just to verify that my implementation is correct, I use it in the same way we did before, once again. And if you look at the results, you will once again note that they are the same.
That's really cool.
This is what map does. If you have any questions, if you ever have any questions about what map does, this is it. That's it. It's not more complicated than this. It's just this. Any questions on map?
No, that's great.
So, Nolan, like, what does map do? Map basically takes a list and then just prints it out?
No, map is going to take, map is a list method which accepts a function as an argument and it will call that function on each element of the list, storing the results in a list that it will return. So here we have some list that we're going to operate on. We have some function that we're going to be calling. We iterate through the list. We call our function on that list item.
Okay.
And we add the result to a list. Oh, that's bad. We add the result to the list that we're going to return, and then we return the list.
Wow, that's pretty cool. So basically, you can manipulate whatever that number is in that list and then store it in another list.
Yes. If you wanted to double all the numbers in the list, map would be a great tool for that. Like, it would be as simple as double equals mylist.map. X goes to 2 times X.
Wow, okay.
That simple.
And is Lambda part of this mapping thing?
Lambda is a Python thing.
Oh, okay.
But a Lambda function in Python is very similar to an arrow function in JavaScript.
Oh, okay. And I don't think you have covered that, right? Because I joined just now, so.
Yeah, that's okay.
Yeah, I'm sorry, yeah.
Did anyone else
There's
have a
also a
question?
map function in Python, right? And it looks similar.
Sorry?
There's also a map function in Python.
That's correct. There is. There is also a filter function in Python. There is also a reduce function in Python. There isn't a for each function in Python. That's just a JavaScript thing. But this style of programming where you use map, filter, and reduce is called functional programming, and a lot of languages support it. Python supports it. There's entire frameworks built around it. If you've ever heard of the MapReduce framework, map is the map that you're used to, and reduce is a function that I'm about to talk about. Any other questions? Okay, then. If we're trying to compute the sum of the numbers, the function I'd recommend is reduce. And reduce is the most complicated of the functional programming tools available to you. Basically, reduce accepts a function that has 2 arguments. The first is an argument called the accumulator. Accumulator. Spelling is hard. And the second is an item from the list. Basically, what it's going to do is iterate through the list, and it's going to pass each item along with the current accumulator value to your function, and then whatever that function returns will be stored as the new accumulator value. When you call the reduce function, you should pass a starting value for the accumulator. So what is this going to do? What this function is going to do is, for each item in the list, it's going to start by adding 0 to the first item in the list. And the accumulator is going to be the result of the first item in the list plus 0, which is 75. It's then going to go to the next item in the list and add that to the current accumulator result. So 75 plus 57 is, I'm not great at this math, 132?
3, yeah.
So the new accumulator value will be 132. And then it's going to move to the third item and keep doing that. And it's going to keep chewing its way through the list and updating the accumulator. As a result, this is how you would sum the numbers in a list. And this can be defined even simpler by using the arrow function. Goes to That's how you can sum the values in a list using reduce. And let's just quickly run this and make sure that it works. A is not defined. Fair enough. I didn't upload those. Round 2. There we go. So when we're using reduce, it works. We get the same result as before. And I feel like this is another good time to stress that the choice of tool that you use is up to you. If you want to use normal iteration, you can always do it. You can always define your own for loops. If you want to use reduce and map, more power to you. That's up to you. They produce the same result. They run in the same time.
Okay.
It's just a question of how you want to think about it. Now, just like before, you may be wondering what reduce actually does. And this is what it does. This is a definition of reduce. Note that now we have 3 arguments. We have the list that we're going to operate on. We have the function that's going to be accumulating a value. And we have the starting value to pass to the accumulator. We initialize our accumulator. We then iterate through the list, calling some function on our accumulator value and the item from the list, and we store the result as the accumulator. And eventually we return the accumulator. And just to verify that my implementation works, I called it using the same logic as before, and it prints 561, just like we expect. Reduce is by far the most complicated of the functional programming tools. And even then, defining it only takes 6 lines of code. It's not that complicated once you can wrap your head around the idea of passing a function to another function. Does anyone have any questions about reduce? Okay. Moving on, let's do a new task. I'm tired of adding numbers.
This thing, Nolan, what is the difference between reduce and map?
So
It
map
seems like
is
the same thing, right?
All right, well, look at the definition, right? When we're doing map, we are pushing the value onto a return list. So
Okay.
map is going to return a list the same size as the list you called it on. Reduce, instead of just controlling how you access things, instead of just saying, I'm going to store the result in some list, reduce says, I'm going to give you the item we're building with, and you can decide what you want to do with it. Anything you do with map could be done with reduce. So if I want
reduce
to,
is a superset.
I'm sorry?
So reduce is a superset of map.
Yes, reduce is strictly more powerful. For example, if I wanted to compute a running sum of numbers, right? You could do that with map pretty easily, but you can also do it with reduce. So mylist.reduce function. Let's use different syntax. It's going to go to acc.push -1 I. And if I remember my syntax correctly, this should work. Let's see. Let's see how I do. Looks like the syntax is wrong. What's going on here? I don't know. I don't remember the syntax in JavaScript. Conceptually, what I'm trying to do here is add values to a list that I'm building as I'm iterating through the array. But I don't remember how to do that in JavaScript, and I'd have to look up the syntax. So, sorry, bad example.
It's okay. It still gives us a good idea.
It's like, I don't know. It is true that anything you do with map could be done with reduce. It just means that you have to manage building the return list yourself.
Mm.
Got it, yeah.
As a general rule, if you can do it with map, you should use map. You want to use reduce when you want to convert a list into a scalar, basically. If you want to add the numbers in the list or compute the mean of the numbers in the list, something like that. But anyway, let's move on to another task. I'm tired of adding numbers, I said. I don't want my list to be as large as it is. I'm tired of working with that large list. I want only small values. So I want to filter out all values that are above 30. I want to keep values less than 30. We could do this using normal iteration. This is going to be something that should be comfortable to you guys. It's pretty straightforward. We define a new list for each position in our array. The value at that position is less than 30. If it is, then we add the result to our list. And if I go to console, if I refresh the page, go to console, you can see that I got all the values that are less than 30. It's just 29 and 11. Note that 30 is not less than 30. So that's with normal iteration. We could alternatively use the for each method. And in order to do that, we have the same general strategy. We start by defining a list. We call mylist.forEach, and we pass it a function that checks the value of x and adds it to the list if it's below 30. And this is a lot like the logic you would use in Python. In a Python function, you would normally do something like small nums equals empty list, for item in my list, if item less than 30, small nums dot append item. That's like the equivalent Python code. And in JavaScript, you would do it like this. And I can quickly run this, show you guys that it works. Hooray, we get the same result using a for each. But I'd posit that the best way to do this, the best way to filter values out of a list, is to use the filter function. It's nice and simple and clean. You have your list, you call filter, you pass it a function that returns true when x is less than 30. So what this is going to do is go through, look at each item, and ask, is it less than 30? If it is, we add it to small nums. And if I go ahead and remove the debugging statement and let this execute, we will get the result we expect. Once again, 29 and 11. It is up to you to decide if this is cleaner than this. Personally, I prefer this, but that's just me. As with the other functions that I introduced to you guys, that we introduced to you on last week, you may be wondering what exactly filter does. So I went ahead and defined a version of it for you. And this is actually the longest of the functions, but it's also very simple. As with map, we define a return list that we're going to be appending to. We then iterate through our list. We check if we call some function on each item. And if that value returns true, then we add our value to the return statement. We then return the list that we built. This is what filter does. If you have any questions on what filter does, try to understand this function. And just to prove that it works, this is me calling my implementation. So here we get the same result. Yay, it works. Any questions on the filter function? No? Everyone gets it? Great. That's all I really have for you guys. Any of you have any questions on JavaScript? We only have about 10 minutes left. I went a little long.
Just a curiosity thing, where you have the in the filter function that you just reviewed, couldn't we replace some of the function with the arrow, or am I?
Yes, we could.
Okay, I just wanted to check
and it would
that
be
right.
even cleaner.
Okay. That's what it's.
That simple.
Yeah, I love that little arrow.
If you want to use the built-in, you can do mylist.filter.
Okay.
X goes to X less than 30.
Okay.
You are exactly right, Sherry.
Well,
Any other questions?
I remember in class we went over the object iteration, where we also used the arrow function.
Yeah.
So basically, it's like a dictionary, and how does the arrow function apply there?
So you can't really iterate over dictionaries directly. Dictionaries do not have the map, filter, or reduce functions. At least I don't think they do. It's possible I'm mistaken. What we were having you guys do is use, so here, let me just show an example.
Yeah, thank you.
All right, so we're in JavaScript. We can call them objects. It's not that big of a burden. 3 goes to 74. Fish goes to 4, obviously. Now, we can't really iterate over that object directly. What we can do is iterate over one of that object's items. So we can call myObject dot keys, I think. I don't know. I'm going to have to look this up. Yeah, it's keys. And what this does is return a list of all the keys in our dictionary. So object.keys is going to return a list 3, fish. And I should be able to just verify that. I have a spelling error. Fair enough. I need a comma. What's the issue now? Isn't it? Oh, yeah. I forgot. In JavaScript, for whatever reason, keys isn't a method. It's a library function. So instead of calling myObject.keys, you call the object library dot keys and pass in your object. There we go. So here we are. We printed our dictionary. We printed the keys in our dictionary, which gave us 3 and fish. Once we have those keys, we can do a lot with them. We can iterate over them. We can map them. We could even use them to get the values if we wanted to. Like, so my vowels, you could easily get them using vowels. I don't remember the function. I'm gonna have to look it up. Sorry, I don't use JavaScript all that often.
When is JavaScript useful?
I'm sorry?
When is JavaScript useful?
Pretty much anytime you're doing anything even remotely web related.
Okay.
You guys remember jQuery?
Yeah.
jQuery is a Java package or a JavaScript package.
Oh, I see.
Even the project that I showed you guys last week, my own personal project with the MTG cards, I had to write a little bit of JavaScript in order to add some functionality to that page. And I can show that to you guys if you want, but
yeah, sure.
That's unrelated, and let's do this first. So we can log the values using the standard built-in library function, but we could also get my vowels by calling map on our keys. Basically, for each of our keys, we look up the associated value in our object. And if I wrote everything correctly, which there's no real guarantee that I did, it should just kind of work. Looks like it worked. Sweet. Our values are 74 and 4. When we use the map, we also get 74 and 4. So yeah, and then the final one is items, I think, which is items maybe.
So is this some of the stuff that we're going to be using with the tables?
Yeah, you guys should be using this
Okay.
relatively soon.
So to create the headers, and then we're just creating a dictionary, but the table is sort of like it's like a list of dictionaries, kind of, right? I've been sort of, I mean, that's the way, I guess that's the way my brain is interpreting it when I'm reviewing, looking at it.
Sure.
Okay.
That's one way to think about it. Entries. Why is it entries? Sure.
You can create a table through a dictionary, like each key can be a column in the table.
Sure, you could do it that way. Representing a table is one of the things that you could use an object for. It's not the only thing, but it's one of the things. In general, you use objects in JavaScript like you would use a dictionary in Python, which can be in a lot of situations. So anyway, that final object method is entries, which is going to give you a list of pairs, which tells you, which maps. So the first item tells me the key and its associated value. The next item shows the key and its associated value. And you can do map on that all you like. So console.log my items .map. Let's say A comma B, let's say key comma item rather, is going to go to, I don't know, key plus item. I think these are all strings. They're not. Let's make all of these into strings so that I can do addition. Because I can't think of anything else clever to do right now. And here we are. I have successfully added my keys to their values.
Cool.
It's pretty much gibberish, but hey, whatever. Insert comma for some reason.
Great.
Not sure why that happened. Yeah. Any other questions about JavaScript before we wrap up?
Is there a way to compile JavaScript besides the browser?
Yes, you could. If you want to, you can download Node.js.
Node.js. What is that?
Node.js. Node.js is kind of like it's basically a way to run JavaScript.
Compiler?
Do like Node.js download. And then you can look around for the documentations and figure out how to run it. If you guys want to, I can show you. I'll actually link to an article that'll tell you how to run JavaScript inside of a Jupyter notebook if you want.
Oh, what?
Yeah. So let's just show you a quick example.
Mm-hmm.
Give this a second to think.
You know, in the class activities, there's that video guide section. And they recommended a website called Plunker, which lets you run the JavaScript right there. Also, that's just an yeah.
JSreview.ipython notebook. So let me see if I can find in Jupyter notebook. I think this is it. Yes, this is it. Pixie dust.
Oh.
We use pixie dust.
Oh,
Cool.
cool,
Nolan. Cool.
So basically, once you get everything set up, you can execute JavaScript code by putting this string at the start of a cell. And then you execute the cell in the same way you normally would using Shift-Enter or the run cell. It takes a little bit to get set up because it's starting a node server. But here, this is actually basically the same code that I was going to show you guys tonight. I actually considered doing this review inside of Jupyter Notebook, but thought better of it because I don't get syntax highlighting. And I like syntax highlighting. But yeah, this is me running JavaScript code in a Jupyter Notebook. It's literally the same code you guys saw earlier. And I'm going to go ahead and drop this link in our class resources, instructor resources. Personally, I don't really think I'm going to use it because syntax highlighting is kind of a deal breaker. Not getting syntax highlighting sucks.
True, yeah. Just opening the browser to run the script is also a pain.
Yeah, it is. If you guys want, you could use like Google Sheets.
Virtual.
If I'm being honest, I use Google Sheets far more than I use Excel. even at work, really.
Mm.
This is a notebook that I created for Magic the Gathering. And the thing that I want to show you is that you can go to tool on any notebook that you own, you can go to tools and then go to script editor. And that's going to open a new script editor that's a lot like if you guys remember the VBA editor that Excel gives you, it's the same idea.
It's not.
And this is the code that I wrote to make that notebook function. And this is just normal JavaScript.
Mm.
And I can execute it kind of how we executed VBA by pressing this button. You can see that it says running script, and now it's finished. And if you guys want to learn more about that, you can Google it or ask me questions in the next review session or in class tomorrow.
Okay.
Any final questions before we wrap up?
No, thank you so much.
Thank you, Nolan.
Just final note, you do not have to use the functional programming tools in JavaScript. You are free to use iteration. It's entirely up to you. Do whatever you're comfortable with. It's just another way to do it. It's list comprehension versus loops in Python.
Right.
If you don't like arrow functions, you don't have to use them. Same thing. All right, well, unless there's anything else, I'm going to wrap it up.
All right, thank you. Thank you again.
All right, thank you, everyone. Thanks, Nolan. Thank you so much. Take care. Bye.
Take care, everyone. See you all tomorrow.
See you tomorrow.
All right.
Thanks.